Something profound has shifted in the grand tapestry of existence. A subtle alteration, almost imperceptible, has taken place. You might not feel it yet, not in the hustle and bustle of your daily life, but the world, our shared home, is fundamentally different today than it was yesterday. The very fabric of reality has been subtly rewoven. A quiet trickle of data, a faint whisper carried on the backs of photons from the inky blackness of deep space, has fundamentally altered our understanding of our place in the universe, our cosmic address, our very reason for being. It has redefined what it means to be human. For all of human history, spanning millennia, we've looked up at the star-dusted canvas above and wondered, are we alone in this vast, incomprehensible ocean of stars? The silence, that profound and unsettling cosmic silence, has been deafening, a constant reminder of our potential isolation, until now. That silence, that heavy blanket of nothingness has just been broken, shattered into a million pieces. Not with a bang, a cataclysmic explosion of light and sound, but with a whisper, a gentle nudge from the cosmos. This is not science fiction ripped from the pages of a fantastical novel. This is the tangible result of decades of painstaking scientific inquiry, relentless dedication, and the insatiable human curiosity that drives us to explore the unknown. The story, this incredible saga, begins 4 light-years away, a mere stone's throw in cosmic terms, with a dim red dwarf star and its orbiting planet, Proxima B, a world shrouded in mystery. Our most powerful eye, the culmination of human ingenuity, the James Webb Space Telescope, stared intently at this distant world, peering through the veil of space and time. What it found, the secrets it unveiled, could ignite a revolution not only in science but also in philosophy, religion, and our understanding of consciousness itself. The initial reports, the first whispers of discovery, were shrouded in secrecy, strange readings that defied explanation, anomalies that challenged our understanding of physics, data that simply shouldn't exist according to our current models. But the evidence, the undeniable truth, became increasingly clear, verified and corroborated by teams of scientists worldwide across international space agencies. What we're about to discuss, what I'm about to reveal, is not a maybe, a hypothesis, or a theory. It is a confirmed discovery, a monumental leap for humankind, a message of a sort, a signal carrying information that has traveled across the vast interstellar void, traversing unimaginable cosmic distances to finally reach us. Here, now. The universe, it turns out, is far more complex, more vibrant, and infinitely more interesting than we ever dared to imagine. So, take a seat, settle in, and prepare to have your perception of reality challenged. We need to talk, urgently, about what's happening out there in the vast expanse of space. Because it affects everything down here on Earth, every aspect of human civilization, every single one of us. The universe, after billions of years of silence, has just tapped us gently on the shoulder, attempting to make contact. It's time to turn around, to face the unknown and see who or what is finally there, reaching out to us from the depths of space. The great cosmic silence, the emptiness that has haunted our dreams for generations, is finally irrevocably over. To truly grasp the significance of this pivotal moment in our understanding of the cosmos, we must first turn our gaze towards our closest stellar neighbor. It's a journey of astronomical proportions, a voyage across the vast expanse of space, to a star system that has captivated the minds of scientists and dreamers alike. Proxima Centauri, a name that echoes with the promise of discovery and the potential for worlds beyond our own. This star, though diminutive in size compared to our sun, holds a key to unlocking some of the universe's greatest secrets. It's a red dwarf, a type of star far more common than our own sun in the Milky Way galaxy. These stellar bodies burn their fuel slowly, leading to incredibly long lifespans, potentially trillions of years. Small, cool, and faint, emitting a fraction of the light and heat of our familiar sun. Its reddish hue is a telltale sign of its lower surface temperature, a stark contrast to the brilliant yellow of our own star. But despite its diminutive nature, it holds an unparalleled significance. It is the closest star to our sun, a mere stone's throw away in cosmic terms. Part of the Alpha Centauri system, it represents our nearest interstellar neighbor. For years, astronomers meticulously scanned the space around Proxima Centauri, employing powerful telescopes and sophisticated techniques, hoping to find evidence of orbiting planets. We didn't know if it had planets, if this small star hosted a family of worlds. Then, in 2016, a groundbreaking announcement reverberated through the scientific community. Astronomers, after years of dedicated observation and analysis, confirmed the existence of Proxima B, an exoplanet orbiting our nearest stellar neighbor. Just over 4 light-years away, a distance that seems vast to us, yet is a cosmic hop in the grand scheme of the universe. It's the nearest known exoplanet to Earth, a tantalizing prospect for future exploration, and a beacon in our search for life beyond our solar system. What makes Proxima B so incredibly special, so deserving of our attention and scientific curiosity? It orbits within the habitable zone of Proxima Centauri, a region where temperatures could potentially allow for the existence of liquid water on the planet's surface. The region where liquid water, the essential ingredient for life as we know it, could exist in a stable state. Suddenly, the search for life beyond Earth had a tangible target, a world that offered a glimmer of hope in our quest to answer the age-old question, are we alone? A world next door, relatively speaking, a cosmic neighbor that beckons us to explore its secrets. But Proxima Centauri is not a gentle, predictable star. It is volatile, prone to sudden bursts of energy and intense radiation. It unleashes powerful flares, eruptions of energy that can dwarf even the most significant solar flares from our own sun. These flares pose a significant threat, potentially stripping away a planet's atmosphere, rendering it uninhabitable. Proxima B is also likely tidally locked, meaning one side perpetually faces its star. One side bathed in the harsh light of its star an endless day, experiencing scorching temperatures. The other in perpetual night, plunged into frigid darkness, a world of ice and shadows. Could life in any form we can imagine possibly survive in such extreme and contrasting environments? The questions surrounding Proxima B were as compelling and complex as the seemingly endless possibilities it presented. Proxima B, despite the challenges it presents, quickly became a beacon of hope in the search for life beyond Earth. And a profound challenge to our imagination, forcing us to consider the diverse and potentially bizarre forms that life might take in the universe. With Proxima B in our sights, the stage was set for a deeper, more comprehensive look, a scientific investigation that could potentially rewrite our understanding of life in the cosmos. Enter the James Webb Space Telescope, our cosmic detective. Unlike Hubble, Webb sees in infrared, peering through dust and revealing the hidden universe. Its golden mirror, 6.5 meters wide, is the most sensitive infrared eye ever built. Webb operates at frigid temperatures, shielded from the sun to catch the faintest signals. Its specialty, transit spectroscopy. When a planet passes in front of its star, Webb analyzes the starlight that filters through the planet's atmosphere. Each molecule leaves a unique fingerprint in the light. This is how we can study the chemistry of worlds light years away. Webb turned this power on Proxima B, searching for signs of an atmosphere, and maybe, just maybe, life. The universe was about to reveal a secret. The dream of finding life on Proxima B began the moment it was discovered. Scientists and the public alike wondered, could there be oceans or life under a dim red sun? Previous attempts to study Proxima B were stymied by distance and faintness. All we had were models and speculation. Until Webb. The first goal, confirm an atmosphere. Any detection would be a triumph. But many scientists warned against optimism. The odds were long. Radiation, tidal locking, and stellar violence made life seem unlikely. As Webb turned its golden eye to Proxima B, the world held its breath. We expected a dead, irradiated rock. We were not prepared for what we found. The first data from Webb's observation of Proxima B arrived. Scientists analyzed the spectrum, the breakdown of starlight by wavelength. There were clear signs of an atmosphere. That alone was historic. But something was off. The absorption patterns didn't match any known natural gases. There were sharp, regular lines, like a barcode, embedded in the data. Every test confirmed it. The signal was real, and it came from Proxima B. The spectrum looked like two signals superimposed, one natural, one artificial. Nature doesn't make barcodes. The data was checked and rechecked, then sent to independent teams. The result was always the same. An artificial-looking signal, undeniable and strange. It wasn't a radio transmission, but a chemical fingerprint, etched into the planet's atmosphere. The whisper from the void was becoming a roar. We had found something profoundly unnatural. The announcement stunned the world. Webb had detected a planet-wide network of artificial atmospheric compounds, specifically complex chlorofluorocarbons. On Earth, these are industrial byproducts never found in nature. Their presence on Proxima B is impossible to explain naturally. This is not a biosignature but a technosignature, evidence of technology. The barcode-like lines were the fingerprints of these synthetic molecules. Proxima B's atmosphere is saturated with pollutants on a scale far beyond anything on Earth. Are we seeing the remnants of a vanished civilization, or an active planetary machine? The sheer quantity suggests a technology operating for a very long time, or with unimaginable intensity. We haven't found life, we've found the unmistakable mark of a machine. What does this techno-signature mean? The scale of CFCs suggests a purpose, perhaps planetary engineering. On a tidally locked world, a civilization might use greenhouse gases to distribute heat and create a habitable zone. Or, we could be witnessing the aftermath of an industrial catastrophe. A world ruined by its own technology. The compound's distribution could reveal more. Are they concentrated or global? Are they stable or replenished? If they're being replenished, it means an active, ongoing process. This could be the most profound discovery in history. A technological civilization, possibly still active, on our nearest neighbor. The questions multiply. Who built this? Are they still there? Are they biological or artificial? We thought we were searching for life. Instead, we found engineering. The puzzle of Proxima B is now about history, purpose, and identity. This discovery changes everything. We are no longer unique as the only technological species in the cosmos. This is a Copernican moment showing we are not the center, even technologically. The psychological and philosophical impact will be immense. It could spark a new era of science, art, and global cooperation. But it's also a warning. Proxima B's atmosphere could be a parable for our own future. If it's a ruin, it's a terrifying lesson about unchecked industry and climate change. If it's engineered, it's hope that technology can solve the problems it creates. The search for techno-signatures will now become a primary focus of astronomy. We've been listening for radio signals, but the real clues are in planetary atmospheres. The hunt is on, and it's broader than ever. We are no longer just listeners, we are cosmic detectives. So where do we go from here? Now that we have a potential target, a tantalizing hint that we are not alone in the vast cosmos, what are the next steps? How do we transform this exciting possibility into a concrete reality? This is just the beginning. The discovery of potential biosignatures or techno-signatures is not the end of the road, but rather the opening of a new chapter in our exploration of the universe. Webb and its successors will focus on Proxima B, dedicating their advanced instruments to scrutinize this exoplanet in unprecedented detail. Mapping its atmosphere, searching for telltale signs of life, or even the presence of artificial chemicals that could indicate technological activity. And searching for more clues, poring over the data, cross-referencing it with known phenomena, and developing new analytical techniques to extract every last bit of information. We'll look at other nearby stars for similar techno-signatures, expanding our search to encompass a wider range of stellar systems and planetary environments. The discovery gives us a clear target, a focal point for our scientific endeavors, a beacon guiding our exploration of the cosmos, and a reason to dream bigger, to push the boundaries of what we believe is possible, and to inspire future generations to reach for the stars. Interstellar travel is now a necessity, not a fantasy. It's no longer a question of if, but when, and how we will traverse the vast gulf between stars. Projects like Breakthrough Starshot will get new urgency and support, accelerating the development of innovative technologies that can propel spacecraft to unprecedented speeds. The challenge is immense, requiring breakthroughs in propulsion, navigation, and communication, but the potential rewards are even greater. But the prize is the greatest imaginable, the chance to make contact with another intelligent species, to learn from their experiences, and to expand our understanding of the universe. A close-up view of another civilization's handiwork, a glimpse into their culture, their technology, and their place in the cosmos. This will be a multi-generational effort, a monument to our curiosity, a testament to our unwavering desire to explore the unknown, and a legacy for future generations. The stars no longer seem so distant. They are within our reach, beckoning us to embark on a journey of discovery and adventure. One of them is now a place of wonder and warning. We must proceed with caution, aware of the potential risks and rewards of contacting another civilization. We are children who have just discovered other houses on our street. We are filled with excitement and anticipation, but also with a sense of responsibility. The universe has invited us to a grander stage. It's time to step into the spotlight and play our part in the cosmic drama. It's time for humanity to step out of its cradle, to leave behind the confines of our solar system, and to venture into the vast unknown. and begin the journey, a journey that will test our limits, challenge our assumptions, and ultimately transform our understanding of ourselves and our place in the universe. The next giant leap is for all of us, a collective endeavor that will require the collaboration of scientists, engineers, policymakers, and citizens from all corners of the globe, the leap to the stars. A leap that will redefine what it means to be human and that will usher in a new era of exploration, discovery, and understanding.